Assalamu alaikum students. Today we will study exercise 5.1, some parts of question number 3. I will read question number 3 for you. If f of t is equal to t square I minus 2tj plus 5 minus tk, g of t is equal to minus ti plus 2t minus 1j plus e raised to power tk, h of t is equal to 2ti minus 3t square j plus 2 plus 3tk, then find the following expressions. Part number 1 is 3f of t minus 2h of t. In first part, we have been asked to find 3f of t minus 2h of t. In this part, we will first multiply 3 with f of t, 2 with h of t, and then we will subtract 2h of t from 3f of t. 3 and 2 are scalars, f of t and h of t are vector functions. We come to the solution of part 1. These 3 will be multiplied with each and every individual components of this vector function f of t. If you multiply 3 with t square I, we get 3t square I. After multiplying 3 with minus 2tj, we get minus 6tj. If you multiply 3 with 5 minus tk, we get 15 minus 3tk. If you multiply minus 2 with 2ti, we get minus 4ti. If you multiply minus 2 with minus 3t square j, we get 6t square j. If you multiply minus 2 with plus 2, we get minus 4. If we multiply minus 2 with 3t, we get minus 6t k. These are the components having I. If we take I common, so we will get 3t square minus 4t in the bracket. The components having j are these two, minus 60j and plus 60 square j. If we take j common, we get 60 square and minus 60 in the bracket. Components having k are these two. If we take k common, so we get 15 minus 3t minus 4 minus 6t in the bracket. Writing the first component as it is, writing the second component as it is. Now come to the third component. 15 minus 4 will be 11, minus 3t minus 6t will be minus 90k. You can see here we can take t common in the first component. You can see here we can take 60 common in the second component. We can take 60 common in the second component. So now we come to the last step of this question, of this part. If we take t common from the first component, we get 3t minus 4 in the bracket I. If we take 60 common from the second component, we get t minus 1 in the bracket j, and 11 minus 9tk as it is. It was first part of question number 3. Now we come to the second part of question number 3. Second part is g of t dot product h of t. There is a dot product between g of t and h of t. You have studied dot product in school. How do you find dot product of two vectors? Now we come to the solution of the second part. G of t is equal to this, h of t is equal to this. You know, students, that whenever there is a dot product between two vectors, we multiply the corresponding components and then add them. If we multiply the first component of the vector function g of t with the first component of the vector function h of t, we get, if we multiply minus t with 2t, we get minus 2t square. If we multiply the second component of the first vector with the second component of the second vector, if we multiply 2t minus 1 with minus 3t square, we get minus 3t square 2t minus 1. If we multiply the third component of the first vector with the third component of the second vector, we get, I mean that if we multiply e raised to power t with 2 plus 3t, we get e raised to power t 2 plus 3t. Minus 2t square will come as it is. If you multiply minus 3t square with 2t, we get minus 6t cube. If we multiply minus 3t square with minus 1, we get plus 3t square. If you multiply e raised to power t with these two, we get 2 e raised to power t plus 3t e raised to power t. Minus 6t cube. I have written minus 6t cube first, and then if we simplify these two, 3t square minus 2t square, it will become t square. I have written this 3t e raised to power t here and 2 e raised to power t here. So it was the second part of question number 3. Now we come to the third part of question number 3. In the third part, f of t, there is f of t cross product g of t. There is a cross product between f of t and g of t. We come to the solution of this part. F of t is equal to this, g of t is equal to this. There is a cross product. You have studied how do you find the cross product of two vectors. We will make a determinant. In the first row, we will write the unit vectors I, j, k, and in the second row, we will write the components of the first vector function f of t. What are the components? T square minus 2t, 5 minus t. In the last row, we will write the components of the second vector function g of t. What are the components? Minus t, 2t minus 1, e raised to power t. Expand this determinant by first row. How do you expand? You have studied already in school and in first year. Write I, then neglect the first column and first row and multiply these two minus and multiply these two. If you multiply minus 2t with e raised to power t, here it is, you will get this minus, multiply these two, 2t minus 1 with 5 minus t, bracket closed. Now we come to this. You know that there will be alternate sign if we expand by first row. Plus minus plus, minus j, ignore the first row and second column and multiply these two and these two. If you multiply t square with e raised to power t, we get t square e raised to power t. If you multiply, there will be a minus sign in between, and then we multiply minus t with 5 minus t, so it will be plus t 5 minus t, bracket closed. Now it will be, then it will be plus k. We will ignore the first row and the last column. We will multiply these two, there will be a minus sign in between, and then we will multiply these two. If we multiply t square with 2t minus 1, we will get this. If we multiply these two and there is a minus sign in between, so it will become 2t square. Then we will simplify it in the next step. Minus 2t e raised to power t as it is. If we multiply this with this, we will get this. How? If we multiply 2t with 5, we get 10t. There is a minus sign, so it will be minus 10t. If you multiply 2t with minus t, we will get minus 2t. There is a minus sign, so minus minus will be plus 2t square. If you multiply minus 1 with 5, we get minus 5. There is a minus sign outside, so it will be plus 5. If you multiply minus 1 with minus t, we get plus t. There is a minus sign, so it will be minus t. I. Now we come to the second component. I have written this I in the last, and I have written this j in the last. Now we come to the second component. This minus sign here with j I have written here, so t square e raised to power t will be written as it is. If we multiply t with 5 minus t, it will be 5t minus t square. I have written this j in the last. Now we come to the third component having k. I have written this k in the last. if we multiply this t square with the 2t minus 1, we get 2t cube minus t square. This minus 2t square will come as it is. Now we come to the last step of this part. I have rearranged it. I have rearranged it 2t square. This 2t square I have written here first in this step. Minus 10t minus 1t will be minus 11t minus 2t e raised to power t. This term will come as it is, plus 5 I. Now we come to the second component, minus. I have taken t square common from these two terms. If we take common t square, we get e raised to power t minus 1 plus 5t. I have written j here. Now we come to the third component. You can see I have taken t square common from these. If we take t square common, this 2t cube will become 2t, minus t square minus 2t square will be minus 3t square. Minus 3 is here, t square, I have taken t square common, so it will be t square multiplied by 2t minus 3, and k is here. It was third part of question number 3. It was our today's lecture.